Hi, my name is Abigail, and I'm here with my little sister,
Danielle.
And today we're going to use a lemon to light up a light bulb. So Danielle, could you roll that while I explain what we need for this experiment? So for this experiment, we're going to need a lemon, a light bulb, 4 alligator clips, a multimeter, a strip of copper, and a strip of zinc. So the first thing we will do is what Danielle is already doing for me, is rolling the lemon. So Danielle, if you could please hand me the lemon. Thank you. Rolling the lemon, it just makes it easier so that I can stick the copper and zinc into it. I want to use a knife so that there's holes in there, so it doesn't make it too difficult to stick the copper and zinc into. A little bit of lemon juice coming out. So I'm going to put the copper on this side, more lemon juice, and the zinc in on this side. Oh, a little difficult. Okay, and for this experiment, we're going to make a series circuit. So, Danielle, would you like to help me connect the wires? So we're going to connect the wire onto this one, right at the top. There we go. And we're going to take our other wires. We're going to connect them to the wires again. Yeah. Perfect. And now we're going to connect these 2 wires to our light bulb. Oh, our lemon has just fallen. Oh, here. I got it. There we go. Wait, let's replay that for a second. Yep, it was here when I realized that the experiment never worked. But wait, why isn't the light bulb lighting up? And honestly, when I was taking that video, I wouldn't have been able to give you the answer. But now that I've done a little bit of research, let me see if I can explain to you a little bit. Well, first, let's start with the fact that the lemon doesn't give off electricity. You see, a battery needs 3 things: 2 electrodes and 1 electrolyte. One of the electrodes would need to be a cathode, which is the one that wants electrons. The other would need to be an anode, which is the one that wants to get rid of its electrons. In our case, the copper would be our cathode and the zinc would be our anode. But wait, where does the lemon come in all this? Well, our lemon would be the 3rd thing needed for a battery, an electrolyte. You see, the citric acid of the lemon reacts with the zinc and loosens its electrons. And since copper is the cathode, it will attract the electrons from the zinc. The electrons then go through the wires and into the light bulb, which makes it glow. Because zinc is a metal that usually donates electrons, and when it's in the citric acid of the lemon, it reacts with it. This reaction is when the acid oxidizes the electrons. The copper then collects all of the electrons, and they then go through the circuit and back into the zinc, where it all starts over again. Okay, so now we know how it works, but why didn't it? Well, by only using 1 lemon, 1 strip of copper, and 1 strip of zinc, we don't generate enough electricity for the light bulb to glow. By only using 1 of everything, we can only get a little bit of electricity. If we were to add more copper and zinc strips, the more electricity we would get. Because the more copper and zinc, the more electrons react to the citric acid and flows through the circuit. The same would go for if we added more lemons to the circuit. When we add more lemons, we also need to add more copper and zinc, which would also create more electricity. Thank you for watching, and I hope I've helped you understand a little bit more about how a lemon, zinc, and copper can make electricity.